I love having full visibility into my entire HomeLab infrastructure, monitoring servers, containers, Proxmox, storage, because I just want to know what's going on everywhere. But once you start to monitor everything, it also becomes very noisy. And at some point, you just have to decide what actually matters and what not. Otherwise, your dashboard slowly turns into a giant wall of yellow and red alerts. And after a while, you stop paying attention or you miss that one important alert. And honestly, I have to admit, this is exactly what happened in my own HomeLab because I just hadn't tuned my monitoring setup for a while. But I've now solved that with Checkmk, the monitoring platform that gives you an incredible amount of visibility into your infrastructure right out of the box. And today I'll show you how exactly I've tuned this setup to reduce the noise, adjusting thresholds, and building alerts that I can actually trust again. So in this video, let's dive deep into infrastructure monitoring, and a big thanks goes out to Checkmk for sponsoring this video. Alright guys, so note, this is not a full Checkmk installation or setup tutorial because I've already made a full deep dive on Checkmk. Of course, I leave you that in the description, so if you're completely new to Checkmk or infrastructure monitoring in general, then watch that one first. There's just one important update though. Checkmk released a new version 2.5 where the Docker image name changed from Checkmk Raw to Checkmk Community. So be aware of that. Of course, I've already made an update to my boilerplates repository, so that is what you can use to easily spin up a new Checkmk installation using Docker and Docker Compose. And because I'm using Checkmk 2.5 in this video, some of the menus may look a bit different than my older tutorials, and throughout the video we'll also use some of the new features like the global search function or background activation, which makes tuning rules and working with Checkmk a lot easier and faster. Now, before we go over some specific examples of the Checkmk monitoring rules and what I've changed in my setup, let us quickly recap how Checkmk works, and let me explain how I'm managing my monitoring environment. Because Checkmk does not just monitor any hosts, it also discovers services on them, and then you have all of these rules that define how these services behave. All of these rules can match to a host name, a host tag, a host label, or service names and service labels. And this is where I believe a lot of people make monitoring harder than it actually needs to be. Because if you set up all of these rules and attach them to all of the individual hosts or services on your system, then your monitoring setup becomes a pile of one-off exceptions that does not really scale well, even in HomeLab. And a really important tip that I'd like to share with you is when you start setting up monitoring rules, first of all, attach labels to all of your Checkmk hosts. For example, here I am managing all of my hosts like the server prod 1, 2, 3, my virtual machines, as well as Proxmox servers. And as you can see here, I'm attaching two labels, the type and the platform. For example, here it's Proxmox, the platform is bare metal. Here on this server, it's type server, the platform is VM. And I'm also managing several Docker containers as hosts to monitor all of the service applications as well. And these usually get the label type Compose and the platform Docker, because I can later say in all of the rule settings, hey, please attach this rule only to hosts that have the label type server or type Proxmox, and not just say, hey, create a new rule for server prod 1 and then copy that rule to server prod 2, and then later on you forget about server prod 3 and so on. So this is really important. Turned my Checkmk rules from fragile host-specific exceptions into reusable monitoring policies that I can really attach to specific groups of hosts. What I also love to do is I love to use the Checkmk UI for exploring the different rules, because this is honestly much faster when you're just trying to figure out things. But once a rule is correct, I want automation. So that's why my real Checkmk rules also live in Ansible YAML files here. And that gives me two things. I can reproduce this setup easily, and I can also remember why a rule exists 6 months later. And because these rules are basically just simple YAML files, I can even let an AI agent help me to review all of these rules and adjust or change certain settings instead of just me having to go through the web UI and changing things by hand. This is, by the way, also where Checkmk 2.5 fits nicely into this workflow, because if you're exploring things, you can easily use the global search function. For example, if you're searching for a rule that sets up a temperature setting on your infrastructure without having to remember where everything lives in the menu. That's really practical. And once I'm happy, I put the rule in Ansible. So this is my preferred workflow. By the way, if you want to learn more about how to use Ansible to automate your Checkmk setup, I've also made a full tutorial on that. So check this out if you like. I'll put this video in the description as well. But just to make it clear, you don't necessarily have to use Ansible to configure Checkmk. You, for example, could also use web UI. This is totally fine as well. So whatever fits your workflow best. I'm not saying that you have to follow my best practices. But anyways, whether you create the rules in the web interface or if you're using Ansible, you're basically always facing the same tasks. Normally, you just let Checkmk discover any services on any of your hosts in your infrastructure, and you just accept all of this. And then it automatically starts monitoring all of these different services on the system. But, and this is important, not every discovered service deserves the same level of attention. The more hosts you will add to your monitoring setup, the more service notifications will pop up in the dashboard, reporting problems or things you should take care of. And then you need to decide, is this actually an important alert or is this just noise? And this is where monitoring gets very personal. Let me make this clear. What matters in my HomeLab does not automatically have to matter in yours. So treat all of the following examples just as an inspiration, not just as copy-paste rules. Because the wrong fix is just mute or disable all of the critical services. The better approach is to actually tune your monitoring system so you only get those alerts that matter in your setup. The goal is not to make every dashboard green. The goal is to make the dashboard useful. So let me show you one example. Let us go into Setup, Services, and then go to Discovery Rules. So here you can see one rule: disabled services. So here I've added 3 separate services that are attached to specific host labels. Remember, these are the groups of all of the different hosts like virtual machines or Proxmox infrastructure. First of all, let me show you this rule here, the disable K3s dynamic file system monitoring, because this was one of the most annoying examples that always popped up in my notification. The problem is that Checkmk discovers any file system mount point as separate services. So all of these different paths show up as different service entries, but treating them like a normal file system is not really useful for me, because these are runtime mount points for containers. And it is really expected that in a Kubernetes cluster, many of these containers appear, disappear, or changed as workloads move around. And when you don't disable these type of services, you always see Checkmk popping up these alerts. Not exactly that kind of alert that you want to see in your dashboard. So therefore I added this rule to ignore this. And here you can see that's a condition: match on anything that starts with file system /run K3s container D and anything that comes after that. So that matches all of these random container file system paths. The next example of disabled services is this here, the Proxmox VE memory usage. Here on this virtual machine, for example, this would have produced a warning message in the dashboard because the usage of the virtual memory is 88%. That's above the threshold of warnings that starts at 80%. When it's above 90%, you even get a critical warning in your monitoring setup. This, by the way, you could also see on your Proxmox system. Here the memory usage is also 88, 89%, so basically the same that Checkmk discovers. But when we log into the actual virtual machine and take a look at what is the real memory usage, we get a completely different value. So this even looks, from a Proxmox side of view, much more dramatic than it actually is on the operating system itself. And that is because from the Proxmox side, a Linux VM can often look like it's using almost all of its memory, because Linux uses available RAM for cache and buffers. And the hypervisor only sees the VM mostly from the outside. But it does not really automatically mean the guest is under memory pressure. Checkmk gives us the much better metric. You can also see this here under memory. Total virtual memory is 62%, so nearly the same that we just discovered on the operating system. This is why in my monitoring setup, I just ignore this service that just sees the memory from the hypervisor side of view, and I use the actual memory service to better see what the VM is actually doing or what the resources are on that virtual machine. The same idea I'm also following for the Proxmox LVM volume groups, because a Proxmox volume group can also look almost full allocated. Note, this is not for the virtual machines, this is for the Proxmox hypervisor itself. So if we just take a look at the disks LVM, you can see this is completely full to 100%. The second hard drive is 98%, so this also looks very dramatic. But of course, that does not automatically mean that the storage I care about is actually full or that the VM is about to run out of disk space. So for troubleshooting or alerting, I use another metric that is much better for this. If we go to the Proxmox machine itself, here on the LVM group PVE data, the data is using 80%, so this is far away from the 98 or 100% usage. So just add a new rule that matches all your Proxmox machines, disabling services that starts with LVM VG and then the .*, so anything that comes after that. This helps to automatically ignore not just the LVM local, also any Ceph storage that starts with LVM volume group. And another service that I also disable, let me just go back to the setup discovery rule, and this is in the network interface and switch port discovery. So here I've added a rule on all of my machines to just ignore any networks that starts with Docker 0 or Docker underscore anything, bridge interfaces, tab interfaces. Of course, Checkmk will notify you when an interface goes down, so you get an alert. And for these temporary interfaces, I don't want to be distracted with all of the alerts of services that I actually don't care about. Of course, these are just a very few examples. I've created some other rules like this, but I think I don't have to go and show you every single rule. I think monitoring is very personally, so don't just copy my rules. Better understand how to actually write them yourself that fit your specific environment, not just mine. But speaking of that, let us also go through the second group of alerts that is a bit different than just disabling stuff, and honestly it might also be a bit more difficult to researching, but these are checks that I actually care about. I just don't care about them at the default thresholds, because instead of just disabling a good check, we can use Checkmk rules to teach the monitoring setup what normal means for this specific host or service. So one really good example of alerts that always annoyed me is the committed memory on virtual servers. That virtual machine has a total virtual memory of about 23 GB, but the committed memory is much higher than the total virtual memory. And this is because the committed memory is not the same thing as the RAM is full. On Linux, applications can reserve or promise memory that they are not actively using right now. So especially on virtual machines, the committed memory can go way above 100% without the system immediately being under real memory pressure. And this is where the default values of Checkmk are, in my opinion, a bit too sensitive. So I think they start at 100% for warning and then 150% for critical warnings. And as you've seen in these examples on almost all my virtual servers, I was getting yellow warnings. But of course, I cannot just disable the memory service, because then I don't get memory warnings at all. And I don't want to ignore this. So I still care about if the VM really starts running out of memory. I created a rule that says the upper levels for committed memory are increased to, let's start warning at 120% and let's leave critical warnings at 150% of RAM plus swap. And I'm attaching this to all of the hosts that have the virtual machine platform label. So this keeps all of my memory checks useful because it stops warning too early when it's above 100%, but it still alerts me when the committed memory becomes too high, above 120% or 150%, so that I can actually investigate problems with the committed memory on that machine. Another good example is the NVMe temperature on all of my bare metal or physical machines. So here, for example, you can see I have services that monitor the temperature of the internal hard drives. So I think by default, Checkmk produces a warning if the temperature goes for an internal drive higher than 35 degrees, and a critical warning if it goes above 40 degrees. And if you see the graphs here, you can clearly see that my internal hard drives are always above 40 degrees. So this would always produce a critical warning on all of my physical servers. But it is still not a problem in my setup because I'm using NVMEs, and NVMe drives can get much warmer than normal hard drives, especially in a small server behind the GPU or under a heatsink with limited airflow. So a temperature that looks scary to a magnetic hard drive or maybe even an SSD is completely normal for an NVMe drive. Still, because Checkmk does not differentiate between the different drive types, it will always produce a critical warning. So therefore, I created a rule to adjust the upper temperature limits, start a warning at 60 degrees, critical at 85 degrees. This is where even an NVMe starts getting hot and it needs to throttle down or it becomes unstable, so I need to investigate this. And here, under the sensor ID, I added the conditions that if a sensor starts with /def/NVMe, the asterisk for anything that comes after that, or for specific names of the NVMe drive models. And then you can also see that Checkmk automatically adjusts these temperature warning and critical warnings in the graph view, and it doesn't produce any false positives for NVMe critical temperature. These are some of the examples that I thought might be worth showing. Again, what matters in my HomeLab infrastructure doesn't necessarily have to matter in your infrastructure. I can just give you the tip: go to your monitoring hosts, see what services are producing yellow or red warnings, and then you just have to go through all of them and find out if there are reasonable warnings or reasonable alerts, or if you need to disable certain services or adjust thresholds in your setup, and create label groups for the same type of hosts in your setup and attach these rules not only for one specific host, but attach them to the same type of host groups. And the one remaining puzzle piece here is to keeping the setup clean over time, because HomeLabs are not static. In a HomeLab, there are many things that change frequently, like virtual machines that appear or disappear, services that you might deploy and then destroy the next week or so. I can just speak for myself. I regularly rebuild VMs, adding or removing containers, services, renaming things. So that's why I usually also configure a periodic service discovery. So just go into Setup Services Discovery Rules and then look for periodic service discovery. Here I configure things like automatically update service configuration, monitor undecided services, remove vanished services, and update host labels. You could also update service labels or service parameters, but I leave them off because I want a little more control in that area. And then perform a service discovery every hour. So that means whenever I'm removing a service on a host or I'm changing an interface or whatever, this automatically monitors any undecided services that appear in the service discovery and remove any of the vanished services. I think this is really perfect for a HomeLab where services change all the time. So yeah, that's basically how I manage my Checkmk monitoring rules in my HomeLab. I hope this video helped you to get your monitoring system under control, or at least get some inspiration of how to set up your monitoring rules, adjusting certain thresholds and so on. So thank you so much for watching. A big thanks goes out to all of my supporters and Checkmk for sponsoring this video. And of course, I'm gonna catch you in the next one. Take care. Bye bye.